COVID-19. You've seen it, you've heard it, you've grown to despise it. But do you really know why this virus has become such a problem in the first place? Let's take a look at the virus through a biological lens and what it does to your body and how. First, let's take a look at what kind of a virus COVID-19 is. In the family of viruses, there's the branch of the nidovirus family. Inside of that family, there's the Coronaviridae family, and then the Orthocoronaviridae family. Members of the Orthocoronaviridae family are spherical and have RNA. Inside of this family, there are 4 types of coronaviruses: alpha, beta, gamma, and delta coronaviruses. The gamma and delta viruses infect avian species, so we'll be focusing on the other 2, which only infect mammals. So far, there have only been 7 kinds of coronaviruses which have been identified. If you want, you can pause the video now to look at the data for longer. Now let's take a closer look at the virus in question. Being part of the Coronaviridae family, the coronavirus is spherical and has its genetic material being a strand of RNA stored inside of that sphere, protected by a hard shell of proteins. On the outside, the virus is covered in spikes of protein. These spikes act as keys to enter your body. I'll explain more later. The virus usually enters your body through your face, specifically through your holes like the eyes, nose, and mouth. The virus is mostly transmitted by physical contact or by airborne particles such as coughing or sneezing. Particles can either enter your face holes directly or they can fall onto your hand, and then your hand makes contact with your face holes. Once in your body, the virus looks for a receptor. The virus attaches one of its spike proteins to the receptor, signaling for the virus to be pulled into the cell. Now that it's in the cell, it begins to reproduce. But before we cover that, we must first take a look at the genome of the coronavirus. Here's a simplified chart of what it looks like. It's quite large for a genome. 2/3 of it consists of 2 open reading frames called ORF1A and ORF1B. Also, for clarification, an ORF is a translatable part of a reading frame that is made up of codons. In the ORF, 15 non-structural proteins are responsible for replication and production of RNA processing and modifying enzymes. But these are non-structural proteins. The structural ones are transcribed from the other 1/3 of the genome. The structural proteins go to the ERGIC, where the incomplete virus begins to bud and mature. Once fully matured, they leave the cell, harming it in the process. Now, for what the virus can do to your body, having a foreign threat in your body triggers your immune system. And when your immune system gets overwhelmed, your alveoli start to inflate, creating fluids that block oxygen and CO2 from flowing to and from your blood. Obviously, this means that people with pre-existing lung issues are at higher risk.